So let's make a new geometry. Let's make a planar patch, as we can see here. Then let's make it a vellum configure cloth, then vellum solver. Okay, of course if we hit play it will fall down, as we can see here, but we have to stop here. Okay, so let's give it a pin so it wouldn't fall down. So let's make this pin, hit enter, and let's hit play. Okay, let's go back one more time. Let's choose it this time right, because I'm using this pin. Okay, anyway, it must give us this sphere, as we can see. I think it's actually from the visualization. Yeah, I think I'm not sure it's from what, but anyway. So if we hit play, so as we can see here, we have this cloth hanging, moving left and right. Okay, so let's increase this number, the stiffness, this number multiply by this number. So let's make it, for example, 100. It will almost give us the same thing. It doesn't change, right? But if we increase this number, so we have much more primitive or point. Okay, and of course it must relocate it again, because this time it's become here. So let's choose this one instead. So let's hit play again. So as we can see, we have a stretching here, right? Before we didn't have the stretch. So when we have more points or primitive, it gives us a better result and it works much better. Okay, so now we have a stretching, as we can see here. Okay, so even if we increase it to 0, it will fall much more, as we can see here. Let's change the substep to 5 to see the result. Okay, it's almost the same result. I'm not sure, but look like the same result. But if we, for example, let's make it 1, and let's make this number is big, as we can see here. Still it give us a stretch somehow, right? We have a stretching here. So if we, let's make the stiffness 10 more, let's see. Still it has the same stretch, right? We want the stiffness to prevent the stretching, meaning the distance to expand from every point. So if we go to the substep, we increase the substep. Let's hit play. As we can see here now, we don't have a stretching. It become like a solid. It has folds, as we can see, but the stretching itself, it's the same. It doesn't stretch anymore, right? So the substep basically control the distance or the stiffness of the stretch. So let's see what else do we have here. Now this number is multiplying. Let's make it 1 back again. This number is multiplied by this number, and this one is controlled. Now we have any scaling, meaning multiply in this number, so it's not going to multiply anything. If we choose scale by attribute, so it will multiply by the value of this attribute, which is called stretch stiffness. Okay, let's see if we have a stretch stiffness here. Now I think we will have a stretch stiffness. No. Okay, so it just give us this name. Okay, it will multiply by the value of this one. So if we, for example, let's first pin to animate all this like this. Then let's make an attribute wrangler. Let's copy this one. Let's paste it here. I will tell him if at stretch stiffness equal 1. That means it's not going to change anything, right? Because this attribute, which called stretch stiffness, is 1. So it will already multiply by this number. So nothing going to happen actually, right? Maybe we need a wind or something, but we'll see it soon. So let's change a little bit of the stiffness so we can see if there is anything happened. Let's say 0.1. So let's hit play again. Yeah, and now as we can see there is a stretch. Why? Because it multiplies the stiffness here by this number, right? 0.1. So basically we have 10% of the stiffness that we have before, so it will stretch with us, right? Okay, maybe also we can make it back again like this 1, and then let's make attribute paint. Okay, we have 1, so it's not going to change, but in this attribute we will change it, the mask, to this name, because it's already 1, so it gives us a red. And in this float we can make it 0.1, and let's choose this one here, and let's put it here. Maybe, of course, we have here Control Shift. Yeah, it will as we can see here, it will scale the brush, right? So let's see again what we have. Is there something will change? Let's hit play. So as we can see here, this part is stretching more than this part, right? Why? Because the stiffness here is much less than the stiffness here, and all the stiffness I'm talking about is a stretch, of course, is a stretch stiffness, right? So that's why we can control it by an attribute, and also by a value. If we just simply make it 0.1, it will fall again, as we can see. Maybe we can control it by both attribute and the scale, so this will fall, but this will fall much more, okay, because this already has a stiffness its stiffness is 0.1, or multiply the original, multiply by 0.1, and we also will multiply it by 0.1, so that's why it's become like this. Next we have damping ratio. Damping ratio simply losing energy, meaning the movement will settle in shorter time. For example, we have here stretch 0.001. okay, as we can see here, it's not going to settle any soon, but let's say if we make it 1, let's see when it will settle. It will settle much faster in general, okay, because it's going to move as we can see here, because it's going to move energy much faster. Okay, so if we don't want this vibration until the object settle and become still, we increase this number, which is damping ratio, right? Okay, so next we have receipt length scale. Actually, receipt length scale is very interesting parameter. Let's make another planar patch like this, and this one let's make it like that, and let's make it like this. And let's reduce this number, maybe reduce it a little more, and let's make a Vellum class. This line actually bother me because here it's saying show guide geometry, which if I uncheck it, it will hide the constraint. This is a guide geometry. Okay, yeah. So then let's make a Vellum solver. Again, it will fall down, so we need to make some pin. Let's make one here, also one here, like this, and hit enter. Now we have it. If we hit play, we have this cloth with a little, not sure if this is stretching or not, but in general we don't, if we increase the sub step, we're not going to have much stretch anyway. Okay, so let's see what the receipt length scale do. For example, let's make it 0.5 and hit. Suddenly it gives us this shape, as we can see here. It shrink. What is happening here exactly? It shrink, meaning the distance, the original distance between every point, it shrink it, it multiplied by this number. Meaning if we have this distance multiplied by 0.5, this means it will be, I think this will be the half. I'm not sure if this is the half or not. Yeah, this is the half. As we can see here, it's become much shrink. Okay, but of course, because we have this point, it changed a little bit of the shape, but just to give a good example. Okay, so in the other side, if we make it 2, hit play, and suddenly we have it expanded. It's not a stretching, but just expanded. That means we have now like extra skin, right? Extra skin length. So basically what it happened, it increased the distance between every point and the other, the constraint. So it expands like this. Okay, and also of course we don't have here something called scaling, but we can control its scaling. Let's see how can we control its scaling. There are many ways to do this. but the easiest way to control it is to control the no, not this one, I'm sorry, to control something called stretch scale. It's called stretch scale, the receipt length scale. If we hover here, let's see what we got. We had receipt length and receipt length origin. Okay, so we'll play on the receipt length itself. Let's see how. So since the receipt length is in the constraint, so we will paint it in the constraint. We don't have to paint it in the geometry and then promote it or transfer it to constraint and all this stuff. We will draw it like this. We will say attribute paint like this, and for example, let's shrink this a little bit. So let's make it like this and make this like this, and of course we have Byeardy Academy. It will be like this. Okay, so we have the scale here. This is 0, this is 1. We'll use it as the mask. But let's see again, where is the receipt length? It's in the primitive, but the mask is inside the point, so we need to promote it to primitive. So let's say attribute promote, which is the mask from the point to primitive. Perfect. Then let's make attribute wrangler, and of course this is a point and we are working in the primitive, as we know, like this primitive. We are working in the primitive. We have the mask here now, but I don't see, yeah, the mask. Yeah, here is the mask. Okay, so let's change it to primitive, and let's say, of course, we will type this one, receipt length and receipt length origin. Okay, so it's float if at receipt length. Of course, I know it's a float because it's here. Oh, I'm sorry about that. Here it's a float. Okay, receipt at length. Receipt at length equal if at receipt length origin. Actually, sorry, origin actually is the origin, and this is the origin is the receipt length that we already having here, which is this one, and then I think I will make it 1 for now, and then we will multiply by receipt length. That is the new one that we are creating now. Okay, multiply by if at mask, this and this. Okay, and of course let's connect this one here. Let's see what we got. Yeah, because it's a 0, so basically it will multiply a 0 in the background and 1, because the mask is containing from 0 and 1, right? If we go to the spreadsheet here, the mask, as we can see, 0 and 1. So if it's going to be 0, it will crash like this. So we must fill it. So I'm sorry, it's multiply. Yeah, it's multiply, but I think it will give us the same. No, actually, it work. as we can see here, the receipt length 1 is here and it becomes 0 here, so it's trying to squash to shrink as it possible. Okay, but of course the stiffness is stopping it. So maybe we want to increase the receipt length here and increase the okay, let's say for example, let's make a fit 0 1, right? Because the mask is 0 1, so we have the F mask. So 0 will be, let's say, 0.5, and the 1, let's say it will be 2, and it will be like this. So let's see again. Yeah, so as we can see here, now we have this expanded and this one is shrink. Of course we can make it the opposite if we want. 0.5. Let's see again. We'll have the completely opposite, as we can see. So it's really fun. You can play with it like a Barbie. Yeah, so of course also we need to increase the resolution to have better result. Last but not least, let's type it in a better way. So we'll simply make a channel F, or just simply channel, both will work fine. We will name this foreground, and this one, yeah, channel another 2, and this will be actually this one is foreground and this one is background. Let's type this one. So now we can change easily as we want here. 0.5, let's say 1.5. Let's hit, I think, enter, shift enter. Yeah, so we can change here, but of course there is something that this one is stable. We will not be able to change it. To change this one, we have to change it from inside here, and this is what we're gonna do in the next lesson.